Thank you.
I don't know. You may know what house I'm going to do. Mr. Kitty. I'm babysitting at his house. He went. Yo, that's crazy. All over exactly. So she said, like,
All right, let's go to page 7. We're going to do some review. We've covered all of our new content. So we'll do some review with slope fields. We'll do some review with solving differential equations. So let's look at number 1 on page 7 here. We're trying to match the slope field with the appropriate differential equation. And again, I think trying to eliminate wrong choices is easier than trying to look for the correct one. So remember, there are 4 things that are easily observable. It's not so easy to look at a slope field and tell whether, is that a negative 1/2? Is that a negative 2? It's hard to tell what the exact slope value is, but we can tell a negative slope from a positive slope, from a slope 0, from a slope undefined. So we're going to use that to our advantage, right? So where do we see a collection of slope zeros? All right, where do we see a collection of undefined slope? Where do we see positive slopes? And where do we see negative slopes? Okay, we may not find everything, but if we can make some general observations about what is true about our slope field, then we can eliminate the wrong ones that doesn't fit those characteristics. So one thing that I see is that we do experience slope undefined on the y-axis, right? We don't see any tick marks there. So that means that x equals 0, slope should be undefined. So that means I should be able to plug 0 into the slope field, into my differential equation, and I should be able to get something undefined, right? So I think with this, just with this true property that we know, which one can we eliminate? Which one of these is not giving us slope undefined if we plug 0 in for x? I think A and B. right? Because if I plug 0 in for x, I'm going to get 0, and 0 is not the same thing as undefined, right? So we know that A and B are definitely out. And then I think if we plug 0 in for x, this is also not guaranteed to be undefined, right? Because if y was a different value, so I think just with this property alone, I think we can eliminate A, B, and C, which will give us the D. But I just want to point out some other properties as well. We also see that on the x-axis, we see that when y is equal to 0, we're getting slope 0. And that is true for this one, right? If I plug 0 in for y, I'm getting slope 0. And also, what do you notice about all the slopes that you see here? Most all the slopes. They're all negative, right? So that's a big property that we can use to eliminate a bunch of wrong choices. And the only differential equation that is giving us a guaranteed negative value most everywhere is this negative y squared over x squared, because y squared and x squared is forcing everything to be positive. And then if I get a negative times positive, it's always going to be negative, right? These other ones are not guaranteed to always give me a negative value, but answer choice D is. So why don't you try number 2, see if you can identify locations where you see properties, and then try to eliminate some wrong choices as you look through. Oh, and also something that it's hard to tell like a slope 1 from a slope 5 from a slope 10, but when your diagonal are all the same slope, that's an indication that this is probably all going to be slope 1s, right? So at all these order pairs, we're getting the same slope, and so that can maybe help us eliminate some choices that we know is not true. So one thing I notice here for number 2 is that I see mostly all positive slopes. So let's see if we can eliminate some wrong choices here. Can I eliminate A? Yes, right. It's possible this gives me negative, right? I don't see any negatives here. So if anything can give you a negative, you can just eliminate it because we don't see any negatives at all. Can I eliminate B? Is it possible for this to return me a negative value? Y squared over X. Yeah, it's possible, right? If X was -2 and Y was 1, this will give me a negative value. Is C going to always return me positive?
Yeah.
Okay, so this is most likely the correct answer. Is it possible for D to give me a negative value? Yes, so this one we can eliminate. This is only giving us negative values. All right, try number 3. Go down your list of properties, list out things that you know to be true, and then try to find ones that are going against what you know is true. Hey, what you guys get for number 3? Okay. Did anyone get answer choice C? So when y equals 2, my slope is 0. So I can eliminate the first one because if I plug 0 in for y, I'll get undefined. And I don't see undefined. Undefined should look like a blank space. And that doesn't fit what we see with A. So this one is out. Answer choice B, this like, I think I'm deciding between B and C here because I don't see any undefined slope. There is supposedly undefined slope for the last one, but we don't see any blank spaces here. So it's between B and C here. But if you look at answer choice B, what slope is this always going to give you? Negative x squared times y minus 2 squared. This is always going to give you what? A negative value, right? So, but we see some positive values. So we know answer choice B is not going to fit what we know to be true here. So answer choice C is better. Okay, try number 4. So two easy properties that I see is at y equals 1, my slope is undefined because there's this gap. But that means if I plug 1 in for y, I should be getting undefined. And that can help me eliminate answer choice B because when I plug 1 in for y, I'm getting 0, not necessarily undefined. And then in quadrant 1, all slopes are negative, right? And I think I can eliminate the last one because if I plugged in anything in the first quadrant, I'm largely getting positive values there. Okay, so I'm down to A and C. So quadrant 1 is negative, quadrant 3 is negative, and 2 and 4 are positive. If I try quadrant 3 order pairs into the first one, I'm getting positive values here, and that doesn't go with what we see here. So I think C is going to be the best choice there. All right, so if you're down to 2 options, then pick order pairs from each quadrant and plug in and see, is it getting something that you know is true? Okay, any questions 1 through 4? All right, I'm gonna have you guys try page 8 on your own later. Let's go into practicing solving differential equations. Okay, page 9. Okay, page 9. The rate at which baby bird gains weight is proportional to the difference between an adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. B of t is the weight of the bird in grams. And then the rate at which the weight is changing is according to this differential equation. Let y equals b of t represent the solution to the differential equation. And then it says use separation of variables to find y equals b of t, and then use the initial condition to help you solve for c. Now, we're going to be going through our process of separation of variables. I know that we're used to seeing x's and y's, but sometimes, especially on AP exams, they may not give you something in terms of x and y's. But if that's the case, you know that it's always going to be time and something else, right? And also, you can look at your differential equation as well. Whatever's in the numerator is going to be your dependent variable. Whatever's in the denominator is going to be your independent variable. So in this case, we're going to treat t like our x, and we'll treat b as our y. So I like my first step to always be cross multiplying, just so that I can work towards getting my my dt and my db nicely separated. So this is my original equation here. And again, whenever they give you a set of parentheses, we largely want to keep those unchanged, because this is trying to get us to put these, to have these two stay together. We want that 100 minus b to stay together. So we really don't want to distribute and lose those parentheses just yet. But I'm going to force this to be two fractions, or a fraction equaling a fraction. And that way, when I cross multiply, I can try to get my dB and dt in their right slots. Okay, so that's always my first goal. My first goal is just always trying to get these anchor variables in their right places. So the next question is, do we have full separation of variables? We want everything related to t's on the right, everything related to b's on the left. Do we have that? No. Okay. So what's out of place? Okay. Oh yeah. Yeah. So that parentheses is helping us remind us that if we want to move the b, we're going to move that 100 minus b along with it. So I want to move this over to the left side. Where's it going to end up if I move it? Denominator. Okay. Now, before I move that, there's also something else that we could move. We don't have to move, but I like to move. What else could we move? Yeah, the 5, it's not wrong if you leave the 5 on the left, but ultimately we want to, eventually we want to get that left side to solve for b. So anything that we can move over, we're going to move over as well. So I'm just going to do two things at once. I'm going to move both the 100 minus b and the 5 and put them in the denominator on the opposite side. So and then dividing by 5, the same thing as 1/5. So I'm going to just do this. Okay, we have full separation of variables. B's on the left, everything else on the right. So now we're ready to take our antiderivative. The right side is just power rule. But the left side, we need to go through a little bit of what? U substitution. What's our U value? 100 minus b. Just be careful that this will produce something other than the 1. So we want to make sure that we keep track of that. Okay, so, but also when we go through substitution, what do you expect? What rule do we expect to be applied here? Natural log. Yeah, it's going to end up being 1 over u du, maybe with a leftover coefficient, but we can kind of see what rule, we can kind of predict what rule that we're going to hope to see on the left. Okay, so go through our u substitution process, make sure that we're keeping track of all of our things here. Okay, so this gives me -1 du over u, which we know is natural log. And then I can bring back my original variable b. So negative natural log absolute value of 100 minus b. So that's the result of my integral of the left side. The right side, 1/5 dt, what does that become? 1/5, it's just coefficient, right? So the dt just becomes what? Just t, yeah. So imagine there's a 1 in front, 1 dt becomes t, the 1/5 just hangs out in front. And plus what? Plus c. Okay, so we're done with the calculus. Now we just have two things left to do. We got to solve for c, and we got to solve for b. It doesn't matter which order you do them in. So everyone may have a different preference in terms of how they want to go about it. But I'm going to solve for b first. I just feel like this is a messier place for me to solve for c. I want to wait for this to be an easier equation before I solve for c, but that's just my preference. So I'm going to work towards solving for b. And then along the way, if I can get to an equation that I find is relatively clean, then I'm going to solve for c. So I'm going to just work on solving towards getting b by itself. So I know I got to move the negative. I know I have to resolve the natural log, and eventually I have to get that 100 minus b figured out. So first thing I'm going to do is just multiply everything through by -1, just to try to get that left side cleaned up. The left side is a nice natural log without the negative in front, so I know I can raise both sides. E is the base to get that relationship that I want to get E and natural log to go away. You know that cancels out. We know that we can break this up into the product of two bases because we can separate that plus c away from the rest of my variables. And we know that e to the c is just one large constant. I'm going to drop the absolute value, knowing that the c will pick up the plus or minus for me. I'm just going to solve for b first. So okay, so there's my general equation. But now I feel like, okay, I've solved for b, and now one last thing to do is to solve for c. We do have an order pair provided for us. We know there's the order pair 0, 20, right? At time t equals 0, the weight of the baby bird is 20 grams. So we can use that 0, 20 to help us solve for c, and then we can get our specific equation. That 0 is nice. It's going to wipe out that e. I can solve for c at this point. If I have my c value, I'm going to go back and update and get my specific equation. So if you don't see x's and y's, don't get thrown off. Just know that, okay, it's usually going to be a word problem if it's not x and y's, and your t is your x, and whatever the other variable is, that's your y. All right, number 2. Back to a more traditional differential equations with x's and y's. Okay, so I want you guys to try this one, and then I'll work on it the same time that you guys do. Okay, get your fractions equaling each other, cross multiply, get your dy and dx's lined up, and then look at the problem again to see, okay, how do I get full separation of variables? Anything related to y's on the left, anything related to x's on the right. Now consider what integral rules you want to involve. Left side is just natural log, but the right side, we got to go through a little bit of what? Yeah, what's our u value? Square. Okay. Hey, we go through your substitution. There's going to be a leftover derivative of 2x. If we solve for dx, replacing x in terms of u, we see that the x's cancel out. That's what we want. But then there's a leftover 1/2. And then cosine becomes sine. Bring back your x. And now you have your general equation. There's 2 things left to do. You want to solve for y and you want to solve for c. But again, the order that you do them in doesn't really matter, as long as we eventually take care of both things. Okay, any questions with us with this steps here? Okay, if you're solving for C at a different point than me, you're going to get a different C value, but it's okay. I mean, at the end, we should all be in agreement. So. All right, page 10, number 3. Does anybody still need this problem here? So try to get 2 fractions so they can cross multiply. dy on the left, dx on the right. Any questions up to this point? Right, so I have my dy dx's in their right places, but now we got to consider, do we have full separation of variables? What do we see out of place? Yeah, so this y needs to move. What else? Dx has to move as well. So I'm going to just do 2 things at once. I'm going to make both swap places to the other side of the denominators on both sides. So that way I can just not to worry. Not if I do one at a time, it just feels like some additional steps here. Let's just make both swap places at the same time and let both go to the denominator on the other side. Okay, full separation of variables. Y is on the left, x is on the right. Make sure that your dy dx are always in the numerator. And it's okay to have x's and y's in the denominator. Sometimes students feel like, oh, like they're doing something wrong. And they start flipping the y's and x's up top, and then you're solving a different problem. Okay, so don't be afraid of letting x's and y's land in the denominator if that's where algebraically it lands, because we have rules that can handle them in the denominator. All right, so we do have full separation of variables, but there's something that we can do on the right side to make this a little cleaner here. And we can take advantage of one of the properties. What's a log property that we can do here? Yeah, if we bring that 4 down, it just makes it a little bit easier because then it doesn't look like easier to identify a potential u value. So if I bring that 4 down, I should be able to kind of spot my u value a little bit easier. Okay, so left side is just natural log, right? There's no need for u substitution. But the right side, we do need to pick out a u value. There is no rule that can handle natural log of x over x. What could be a good u value? Yeah, natural log of x. If you're thinking x, just remember that we're never going to do a u value just for x, because then it's a 1-for-1 swap, and you're not making the problem any easier if you're doing a 1-for-1 swap, right? The whole point of u substitution is you're trying to make the problem easier. So if you're just replacing one variable with another variable, then you're basically still looking at the same problem. So we do want our u value to be more than just x. So natural log of x is going to be a good fit for the u value, because the derivative is 1/x, and that should handle that x sitting in the denominator. All right, for u, we can apply power rule there. And the left side we said is power rule, right? Oh, sorry, natural log rule. I'm just cleaning up that right side, bringing back my original variable x. This one, this problem doesn't give me an order pair, so the best we can do is solve, get the general equation, and we can stop, right? You're not expected to do a specific solution if the problem doesn't provide you an order pair. All right, number 4. This one, we are expected to find a particular solution because there's order pair that can help us solve for C. But one thing at a time, let's work on this, getting the general equation first. Okay, I replace y prime with dy dx. I try to get the two fractions to be lined up so I can cross multiply. When I cross multiply, my initial goal was to get my dy dx's in their right places. But at this point, do we have full separation of variables? Yeah, we already have it, so there's nothing more to move. It doesn't, when we cross multiply, it doesn't guarantee that we have full separation, but sometimes that happens, and if it does, then we can move directly into our integral step. The left side is just what rule? Our rule. Right side, we got to do a little bit of substitution, our u value being the x. And so it's good to recognize where we are in the problem. We know that we're done with the calculus, and there's two things left to do. You have to solve for y, you have to solve for c, but you can do them in any order that you want them. I'm going to wait a little longer to do it. If I feel like if I can get rid of that 2, I should have an easier equation before the square root sets in, and then solve for my c value, and then continue getting to my y value. So I find this to be a relatively clean equation for me to kind of pause and solve for c, because my next step is square root. So I prefer to get my c value out of the way before I deal with the square root. So I solve for c. C is 25 minus 4/3. You can use your calculator. I just did common denominator, and I got 71/3. This case, I do have to involve square root to get that y down. But if I do square root, what's going to happen? Plus or minus. These are two separate solutions. You want to choose the one that is appropriate for the problem. Which one are we going to choose? The positive or negative square root? Positive, because that's the only way we can get a 5 to show up if we plug in a 0, right? If we choose a negative square root, we'll get a -5, and that doesn't fit the order pair that's going to live there. So if you're dealing with a plus or minus square root, choose the appropriate solution based off of the y value, the sign of the y value for your order pair. And there's no need to clean anything up. As long as you have your c value solved for and your y by itself, we can stop. All right, page 11. Does anybody still need this? Okay, try number 1. For number 2, I'm gonna cross multiply first. That way, otherwise, if I replace y prime with dy dx, I get a complex fraction. I just cross multiply first, then replace y prime with dy dx. Feels a little bit cleaner. So I cross multiplied again, and I get dy equals 6y times 3 minus x dx. What's one thing that's out of place that we can move? Just a y, yeah. We don't have to move the 6 along with it. The y and 6, they're being multiplied. If it was 6 plus y, then yeah, we got to move that 6 along with it. But here, only move the y. The 6 doesn't have to move. Okay, natural log on the left, power rule on the right. Page 8, 12, and 13 all. So this will be due Wednesday. Just have some more practice with slope fields and then have some more practice with differential equations. And I'll give you a quick worksheet on Wednesday. We'll work on that Wednesday, Thursday, Friday for this.
What?